factoring it out.
Okay.
Oh, I see what you mean, right. In this problem, not P equates to P on this worksheet. Yes, sir. Okay, I see what you're saying. That's correct. So, anybody want to take a guess and they think they might know what it is? Go ahead, sir, please.
Not P and then in parentheses Q or not Q.
Perfect. Thank you, sir. Excellent. Okay. Think of it like factoring a common factor out, okay? Notice that there's a common not P. Notice that there's a common and. So basically what the gentleman did was he factored out not P and then the and what he was basically left with is Q or not Q. Does that make sense, guys? It's just like a greatest common factor. Just smash them together, okay? If you're not good with factoring, sorry, okay? Or you can just use the sheet and kind of try to work your way back. Okay, I think at this point we're basically done. We just need 2 more steps, and I think we've actually executed those steps before. So, can somebody tell me what to do with the Q and or not Q in this, or what law that might be? Yeah, if we look at this, okay. So did you say associative, ma'am?
Yes.
Unfortunately, for this one, we can't use associative because there's 2 different logical connectors.
Negation.
Right, the negation law. Very nice. Okay. Guys, remember over here when we had P or not P? It was a tautology. Well, now we have Q or not Q. So indeed, ma'am, it is a tautology. So we're going to say not P and T, okay, is supposed to be equal to not P. And that's our negation. And then this time, okay, remember last time we used universal bounds because it was an or? This time we're not going to use universal bounds, okay? What's the other one that we need to use because it's an and between there? The identity law, okay? So, again, make sure when you guys are looking at this, make sure the logical connectors match up to what's on the worksheet, okay? So, by the identity law, not P is indeed equal to not P in this problem, okay? All right, please, sir.
Going back to the last one,
Yes, sir.
the T or not, or T or Q. On this sheet, it says for universal bounds, P or T equals T.
Correct.
So
Why did
we
we
use
hold
Q?
on. Oh, it's just, you know what, it should be P or T is equal to P. I'm sorry, make that change on the sheet. Whatever moron put this together, must have made a terrible error on that. So, let me bring it up and show you guys specifically what the gentleman caught, the moron that made this sheet. Okay, under universal bounds, instead of it saying P or T is equal to T, change that, and this should be equal to P. Okay, thank you for catching my moronic, or whoever's moronic thought it was making this up. Okay, I apologize, guys. Okay,
I assume it's the same.
and it's the same thing on this one. It's P. Yeah. Well, P and C. I'm gonna have to look these over.
I think P and C are
Yeah, you're right. P and C should be a contradiction. P or T should be P though. So this one's correct. This one's all good. Oh, shit. Sorry guys. Now I'm confusing myself. Okay, but that one's good, but the other one should be a P. I apologize. Thank you, sir, for catching me. Okay. So, questions about this Boolean algebra stuff? All right. What are the trade-offs between truth table and Boolean algebra? Let's talk about that. All right. Like, when would you guys use a truth table as opposed to Boolean algebra? Because they both do the same thing, right? We could have proved both of these with a truth table. Andre?
I feel like you'd use a truth table if the problem you're working on isn't as long.
Correct.
Because you can do bigger ones a lot quicker.
Right, because you can bully it, right? You
Yeah.
can just do brute force. That's the trade-off, okay? Truth table is just brute force. It always works. But if it's a long statement, you're going to be sitting there for a long time. If you're good with Boolean algebra, you can literally probably do the problem in a minute, okay? So it's much less taxing to do it if you're good with it, okay? So I'm just presenting both of these to you guys. On the examination, I'm going to be specific. I'm going to say prove by truth table or prove by Boolean algebra. So you got to know both of them. Well, you don't have to. You'll just get that problem wrong if you don't, okay? All right. Here's what I'd like for you guys to do, okay? This is an important problem, okay? It's a tough problem. So I want you guys to try letter C, okay? I know it's a difficult one, but work inside the parentheses first, okay? I'll give you guys about 5 minutes to work through it. If you want to work with the person next to you, that's great. If you think the person next to you sucks, then maybe you suck and you're the problem, okay? But give it a shot, okay? Let me know if I can help you guys out with whatever I can, okay? Yes, sir, please.
I showed up late one day, I never got one done.
Oh, you need one of the sheets, that would be helpful, wouldn't it?
You wouldn't mind.
Not a problem, there you
Thank
go,
you so
Fred,
much.
not a problem. Do you need anything else, or, syllabus, or,
I got this.
you got that? Okay, did you get the
I
syllabus?
can bring it online if I need to.
There you go, my friend.
Thank you.
You're welcome. If you guys need assistance, don't be afraid to ask. I won't bite your face off. Unless you're into that weird stuff. Think about trying to do a truth table for this animal. It'd be pretty brutal. I think with bullying algebra, we might be able to do it in 5 or 6 steps. Sir,
In order to do the distributive, does it have to be within like each and every statement? Or can you like, so if 2 statements are true, one is false, can you not use distributive there? It's like and,
Oh, right, yeah, it has to be the exact form that's, is that what you're asking, like if it's?
Same letters too, same.
Oh, correct, it has, well, it doesn't have to be the same letters. So it just basically has to be 3 different statements. So it could be like a P would be your P, the Q would be your Q, and then like maybe not P would be your R. Okay, so if you have a not P, that's a different variable. That might, is that what you were asking? Maybe.
well, I think nonetheless I figured out that I can't do that.
Okay. Welcome to being married. Yeah, this is one of those things you guys might just have to go home and hash out for yourselves for a half hour or an hour. It's just tough stuff. Sorry. But it's not physics, thank God. Sorry. You need a hug then. I'll give you guys a couple more minutes to finish up and then we'll go through our answer together. For those of you guys that arrived at an answer, how many steps did it take you? Just curious. About That's what I did when I did it in my head. I got 5 steps. And if you guys did a truth table for this, oh, Jesus, that would be hideous. No thanks. Okay, guys, so let's try to formulate a solution to this, okay? So I've asked that you guys work inside the parentheses first, all right? Although you could have gotten the answer by using the Morgan's property first and sort of like allocating the not to both of those, although it might make it a little tougher to do that, okay? I always tell people work inside parentheses if you can. So, for those of you guys that worked inside parentheses, what rule did you use to maybe simplify this expression from what it was?
Distributed?
The distributive property. In fact, it's just like what we did over there when we factored out the not p, okay? So, sir, can you tell me when you were done with your distribution, what did that look like, please?
Not P,
Mhm,
then and,
mhm.
then Q, or not, or Q.
Or not, oh, yeah, or Q or Q.
Q.
Okay. So that looks good. Okay. All right, so is that good with everybody? Any questions as to how he did that? He basically factored out the not P. All right, and he was left with Q and Q. Okay, so we're also still left with the P and Q, but that's not a big deal. Okay. So I'm hoping that now that we've gone through and factored that by using the distributive property, that it might be fairly easy to see what's going on inside. Okay? So guys, if you have two of the same thing right next to each other, doesn't it look like if I have black pen or black pen, I've got black pen, okay? So it's the same thing. If I have Q or Q, that should be equal to Q. And I think there's something on your sheet that has P or P, that should be equal to P. So can somebody tell me if it was Q or Q, that should be Q. What rule is that, by the way, sir?
I was gonna go back up to the very top, the second part, it's not P and not Q.
Oh, I made a copy error, which would screw the whole thing. That's strike 2. Wait, one more strike and I guess I have to go over to the beach. Sorry about that, guys.
So that changed the second one to.
Yeah, that would change this, which would make, okay, there we go. Sorry about that, guys. Okay. So, if I have Q or not Q, it's the same thing as either P or not P. So, I think we said that this is going to be a tautology, isn't it, guys? Okay.
Negation.
So, this will be a T. And is that the negation law?
Mm-hmm.
Okay, thank you. So this is going to be not P and T, or P and Q, okay? And that's our negation law.
Should there be, we have not outside the parentheses, but should there also be another negation?
Right here. All these copy errors, man, suck. So it's a lot easier on a piece of paper, I think. So, but thank you guys, I really appreciate that you're checking me out. Wait, that sounded weird. That you're checking my work out. Okay. All right. If you look inside the parentheses, not P and T is going to end up being not P. So we have not P, or P and Q is equal to P. And what was the rule where you have P and T? Was that the identity?
Mm-hmm.
Okay. So if you have something and a tautology, it's always going to end up being the something. Okay. So this is going to be our identity property. I think it's almost bleeding you upside the head that not P is just going to be P. Okay, so we have P or P and Q. And by the way, you could have skipped this step and you could have just gone right down to this. Like you could have gone from line 3 to line 5 if you just wrote in the double negative in there. Okay, you don't have to do that, but it might be helpful for you guys to see all the steps. Okay, so this is our double negative property. Alright, and then finally, I think there's a property on the worksheet that exactly gives this identity right here. So what's the last law that you guys would need? The absorption law, right? If you look at your absorption law, P or P and Q just becomes P automatically. So this is P is equal to P, and that's absorption. Okay. So, generally, okay, I've taught this course for, oh geez, this is probably the 20th time I've taught this course, all right? This is one of the most difficult things at the beginning of the course to do, okay? So if you're a little bit overwhelmed with this or blown away with it, make sure you guys go home, look over it for a good half hour, okay? It's definitely a difficult topic. Work through some of the homework problems. If you need help, come and see me, okay? So, but I'm just saying it's not like one of those things where you can just sleep on it like a truth table and get it fairly easily. Okay? All right, questions I can answer about the Boolean stuff before we move on. Okay, sir?
How do you use a distributive if there's no R?
Oh, that's a good question. When you look at this, see how these two are the same? So think of those as just like P, okay? Because what's actually happening is, if you look at your distributive law, it's just a placeholder. So this is the P. This Q would be the Q, but I want you to notice that these two are different. So this would actually be the R. It's a placeholder. So anytime you have anything that looks different, it's a different variable for that. Okay? Does that make
Yeah, that
sense?
does.
Okay. So yeah, when you guys are doing this, think of the P, the Q, and the R as just placeholders for anything unique. Okay? That's a good question. Okay? I think the sooner you guys realize that and see it, the easier that these will be to try to work down. Okay? That's a really good question. Thanks. Okay. Other questions, guys, I can answer for you all about this.
So it's like a follow the PEMDAS, always do the parentheses first.
Yeah, basically, if you think of it like the order of operations, you do your parentheses, you do your nots, okay? Because in computer science, does it not have one of the highest precedences as well, okay? Your logical connectors, like your ors and ands, have the next highest, and then your conditional stuff. So, and I don't know